Hello, everyone. Good afternoon. My name is Terry Goldberg. I'm the Executive Director of the Northeast Waste Management Officials Association, and I want to welcome you to this afternoon's, what's this afternoon in the East Coast webinar. We're going to be having an overview of lithium-ion batteries, their uses and recycling. This webinar is co-organized by the Northeast Waste Management Officials Association, or NWMOA, and the Northeast Recycling Council, or NERC, and I'm joined on this distinguished panel by Lynn Rubenstein, who's the Executive Director of NERC, who is helped to pull together this webinar today. Please note that this webinar is being recorded, and please use the question box in the control panel. I see somebody's already put a question in the question box, but it's a gray row toward the bottom of your control panel. If you want to make sure your control panel is visible, click on the orange arrow at the top of your control panel, and you should then see toward the bottom the question box. You click on the square with a diagonal line through it, and you should be able to see the question box blow up, and then you can post your questions. We will make a recording of this webinar available both on the NWMOA and the NERC websites. NERC is much more prompt about that than NWMOA, so that probably will be up there tomorrow. NWMOA will be up in the next few days. So yes, we will be posting the recording of this webinar. We will also post the slides on both of our websites. And you will receive a link to where those materials are posted. Before we get going on the webinar, I just wanted to let you know who helped to plan this webinar with NWMOA and NERC. We really partnered with a great group of colleagues from organizations in our region, including Mass Recycle, the Northeast Resource Recovery Association, or NRRA, and the Solid Waste Association of North America New England chapters, both Northern and Southern New England. And you can see all of our distinguished links to our various websites here, but it was really a team effort putting this webinar and the next webinar we're going to be holding next week together. And we really appreciate all of the hard work and assistance that all of the groups that contributed to this webinar did for today's events. The particular organizers from each organization include obviously myself, Lynn Rubenstein, but Gretchen Carey from Mass Recycle. She also was with Republic Services. Reagan Bissonette, she's Executive Director of NRRA. Brian Card is the head of the SWANA Southern New England chapter. He also works with Waste Innovations. And Kevin Roach, he's with the Northern New England SWANA chapter, and he works at Eco Maine. So all of these folks really are responsible for pulling us together for this webinar today. Just wanted to make you aware of the upcoming webinars that we've been planning. There's two more on lithium batteries, one coming up next week on the 25th at the same time. And we'll be hearing from various waste haulers, storage and processing facility operators about how to reduce the risk of fires associated with lithium battery waste management. We're doing a webinar on June 8th on environmental benefit calculators. That'll be at 2 o'clock Eastern. We have a webinar coming up on lithium battery recycling, the actual process of recycling lithium batteries. That'll be on June 14th at 1 o'clock Eastern. Then we have some other topics we're working on for webinars, one on EPR for packaging, and looking at different models for EPR for packaging. That'll be June 17th at 1 o'clock Eastern. And then we're doing a webinar called Growing the Upcycled Food Economy on July 14th at 1 o'clock Eastern. So stay tuned and join us for these upcoming webinars. I think they're going to be excellent. We've got some great presenters lined up for those as well. And with that, I'm going to introduce our three presenters today. We're first going to hear from George Kirchner. He's with the Rechargeable Battery Association. He has served as the Executive Director of PRBA, or the Portable Rechargeable Battery Association, since 2006. He represents PRBA and its members in the United States and internationally on issues associated with the safe manufacturing, handling, transport, storage, recycling, and disposal of lithium batteries. He also represents PRBA at international transportation forums such as the United Nations Subcommittee of Experts on the Transport of Dangerous Goods, International Civil Aviation Organization Dangerous Goods Panels, and International Maritime Organization Subcommittee on Carriage of Cargoes and Containers. He has also worked as a senior regulatory analyst with the law firm of Wiley Rein, LLP in Washington, D.C. since 2005, with expertise on domestic and international transportation of new and waste lithium batteries, electric vehicles, and portable electronic equipment. Our second presenter will be Eric Fredrickson. He serves as the Managing Director of Operations for Call to Recycle, where he is responsible for the development and enhancement of the organization's operations to optimize performance and efficiencies while upholding the organization's commitment to safety standards and compliance obligations. In partnership with the senior leadership team, Eric drives continuous improvement efforts to help enhance Call to Recycle's program throughout the US and Canada. With more than 20 years experience in engineering and operations management at leading transportation solutions providers, Eric is known for his expertise in logistics, safety, and corporate compliance. He received his Bachelor of Science in Industrial Engineering from the Georgia Institute of Technology. And finally, our third presenter will be Kirk Sander. He leads the National Waste and Recycling Association's efforts to make the industry safer through engagement with their members and federal agencies, specifically the Occupational Safety and Health Administration, or OSHA, and the Federal Motor Carrier Safety Administration. He serves as the secretary for the Z245 Standards Committee. So we'll take it away with George. Thanks, you guys.
George, you now have controls.
Thank you. All right, let me expand this a little bit. All right. Everybody see that okay?
Yeah,
you
looks
guys
great.
might
Thank you.
want to minimize your webcams. That'll
Right.
expand the screen. Or get rid of your webcams while you're speaking.
Was that better? Okay. All right. Well, thank you for the introduction. Hopefully everybody can see that screen okay. When I was asked to give this presentation, this is something that I've done in the past, and it's been a while since I've done this. We get a lot of questions at PRBA about lithium battery chemistries, lithium ion versus lithium metal, what applications are preferred for different technologies, different chemistries, and how lithium ion has evolved over the last 30 years. If you recall, so many of you know, lithium ion batteries first hit the marketplace in 1991. So it's been a good 30-year run for lithium ion, but people tend to forget about how it got started, what the initial applications were all about, and how lithium metal fits into the scheme of lithium batteries, both from a product use, applications, recycling, and end of life and such. So I wanted to touch on both lithium ion and lithium metal batteries, explain the differences there, the different applications, and how they move through the transport chain, et cetera. And I also want to talk a little bit about fire code issues towards the end of the presentation. So when I was thinking about this presentation, I was thinking, what are the number of lithium ion battery powered products do I have in my house? And so as I was going through, my wife said, you should just put everything out on the back porch and just take a photo of it and show, the different battery powered products you have in your house. And I thought, that's not a bad idea, because had you been to my house 5, 6, 7 years ago, you probably would not have seen half of these products at my house. And that's a great reflection of how lithium ion batteries have entered marketplaces that they weren't in 5 or 6 years ago. So for example, the chains of the pole saw you see here in the background, that used to be powered by a 2-cycle engine. And again, a 2-cycle gas-powered engine, and now I've got a big lithium-ion battery. We have 2 leaf blowers, both powered by lithium-ion batteries. Chainsaw powered by lithium-ion batteries, used to be powered by gas, 2-cycle, engine there as well. The light, I'll call light duty vacuum, and of course you see the notebooks, tablets, e-readers, and cordless drill over here. But again, you can see just it's a great example of how what I don't have in my house is a lithium-ion battery-powered electric vehicle. Of course, we do have a hybrid vehicle with a nickel metal hydride, which we absolutely love, but we haven't gone full in on the EVs yet. I'm not sure if we ever will, but this is a great example, especially on the portable side, of how portable lithium-ion batteries have made their way into the marketplace, into a lot of different products that you would have not seen 5 years ago. I mean, the chainsaw is a great example, probably one of the greatest inventions of all time, in my opinion. That is just a wonderful tool to have around the house if you're doing light duty chainsaw work and such. But again, great example, and I'm sure I'm not unique, but again, you can just see the different size, different form factors of lithium-ion batteries that are here in the photos. And so when I get questions about the differences between lithium metal and lithium ion batteries, I always have to start and to explain that, generally speaking, lithium metal batteries are non-rechargeable. They're often referred to as primary batteries. They contain metallic lithium, but they also contain, most contain an organic solvent, which means if they're abused, there is some flammability characteristics associated with it, which is why the U.S. Department of Transportation regulates lithium metal batteries as hazardous materials, and they're also regulated internationally under the dangerous goods regulations based on their lithium metal content. So you've got, generally speaking, lithium metal batteries that are non-rechargeable, and that's the bulk of the lithium metal batteries you see out there. I've got a little footnote here in the bottom about rechargeable lithium metal battery chemistries. They absolutely are in the marketplace, no question about it. You're seeing, and when I get towards the end, I'll talk about a different type of lithium metal battery that's rechargeable, with the solid electrolyte, which is making its way into the marketplace as well. But for the most part, at the consumer level and at the portable battery level, lithium metal batteries are the over-the-counter type that you see that are non-rechargeable. You also see them in a lot of industrial applications, which I'll talk about in just a minute. On the lithium-ion side, we're all very familiar with that chemistry, and often it's referred to as secondary batteries, and of course it's rechargeable. It does not contain metallic lithium, so a lithium-ion battery will not contain any metallic lithium at all. They do, like lithium metal batteries, often will contain a flammable organic solvent. And under the U.S. Department of Transportation regulations, they're based on the watt hours, how much energy is in that battery. So a good comparison between the two. Lithium metal, again, because they contain metallic lithium, regulated by DOT, Department of Transportation, based on their lithium metal content. Flammable in some cases with an organic solvent. Same thing with lithium ion. They do contain an organic solvent. They do present some fire risk, of course. But because they don't contain metallic lithium, they're generally regulated based on their watt hours by the U.S. Department of Transportation. The different lithium-ion battery chemistries, and again, a little footnote here at the bottom, this is not an exhaustive list. I want to emphasize that. We generally see about 6 different chemistries in the marketplace today, depending on the application. Again, there's different mix. Called chemistries or recipes out there for lithium-ion batteries, but these are the 6 primary chemistries that you see out there today in different applications, from portable applications on up to the large format electric vehicle and stationary applications. One of the chemistries I often like to touch on is this lithium iron phosphate technology that you see, or chemistry that you see in the marketplace for many different applications. You don't see it in electric vehicle applications, but you do see them in stationary applications. You do see them in medical device carts, for example. You may see them in marine applications for trolling motors and that type of thing. It's a very popular chemistry for a lot of different reasons, but the questions we always get is a lithium iron phosphate battery a lithium ion chemistry? And absolutely it is. So again, just keep that in mind when you're thinking about different lithium-ion battery chemistries out there. It's all based on that lithium-ion chemistry. They just have a different chemistry depending on the application that it's designed to power. On the lithium metal battery side, there's 5 or 6 primary lithium metal chemistries that you see out there for both consumer application and what I'll call industrial, military, aerospace application, and also medical devices. Lithium manganese dioxide, very common consumer type lithium metal battery that you see you can buy over the marketplace, whether they're small coin cells or they're what we call CR123As that we see at many retail stores. Lithium sulfur dioxide, lithium iodine, these are typically not consumer type batteries that you can find, but again, they're manufactured in very large numbers by specialty manufacturers. Lithium thionyl chloride, again, a very popular chemistry in many military and industrial applications. And then lithium iron disulfide, again, another chemistry that we see at the consumer level, a very popular chemistry as a something to replace alkaline batteries. It's a lower voltage, 1.5 volts. You typically will see Energizer, Duracell selling AA and AAA lithium iron disulfide batteries at retail. Again, great chemistry, very stable, very long shelf life. But again, the one thing about these lithium chemistries to keep in mind is that they do have a very long shelf life. All lithium metal battery chemistries have a fairly long shelf life, so they can sit in at retail, they can sit at your house and be used after even 2 or 3 years of sitting in the drawer or sitting in your product. So again, a very stable, long-lasting, safe technology, and all these different ones you see that have been around for many, many years. Lithium iron disulfide is probably the newer of the chemistries, but it still has been around for a good 5 or 10 years again, as a alternative to the alkaline 1.5 volts. I had mentioned before that there's a lot of activity involving solid state lithium batteries in the marketplace today. This seems to be the next big thing when it comes to lithium batteries. I often get questions of, George, what's going to replace lithium ion? Well, as we speak today, nothing is going to replace lithium ion for the near future, but there is a lot of activity out there involving solid state lithium batteries. And this is that rechargeable lithium metal battery chemistry that I mentioned at the beginning. This is intended to be a safe, quote unquote, safer technology or safer chemistry than lithium ion. But again, there's a lot of companies that are generating a lot of buzz in the industry about their technology and how this is going to transform the industry for a couple of reasons. Higher energy density than lithium ion, and that's the big selling point, and a quote unquote safer design or chemistry maybe than lithium ion. But again, I emphasize this point. Don't believe everything that you see on the internet when it comes to solid state lithium batteries. But again, there's a lot of effort in this particular space to see a new rechargeable lithium battery chemistry enter the marketplace. And these 5 or 6 companies that I've highlighted here, again, I just pulled these off the internet, where you see a lot of interest in their technology for both primarily, I would say, large format applications and stationary applications. But again, remember that it's a little bit different than lithium ion. Okay, this is not a lithium ion technology. These are rechargeable lithium metals, so there is a big difference between the two. But again, you may have seen all the press releases and the articles on this different solid state type of technology, but that's the direction a lot of the battery industry is headed. But for now, and I would say for the next 5 or 10 years, it's still lithium ion, and which is why you see a lot of factories going up around the world. These gigafactories or mega factories, and a lot of agreements or partnerships between battery manufacturers and automobile manufacturers to ramp up production for lithium ion batteries. But again, don't lose sight of this solid state lithium batteries that may be coming into the marketplace in maybe 5 or 10 years. So why lithium? You know, there's a lot of reasons why lithium is the preferred technology, whether it's lithium ion or lithium or it's lithium metal. The big advantage, of course, is the high energy density, rapid charge and high load capabilities, long cycle life, as I said before, and extended shelf life, no maintenance compared to, say, lead acid batteries, where you may have some maintenance associated with that. Good energy efficiency, low self-discharge. What's not on here is there are no heavy metals associated with lithium battery chemistries. We see a lot of lithium, and I'll talk about this in just a minute. We see a lot of lithium ion batteries displacing lead acid batteries in certain applications. And again, it's not the perfect fit for many lead battery applications, but we do see lithium displacing lead acid in certain applications, and I'll talk about that in just a minute. Some of the limitations with lithium, certainly there are some limitations. It requires more sophisticated protection circuitry to limit voltage and current than, say, lead acid batteries. Always the possibility of venting and thermal runaway exists when it comes to these batteries. It degrades at high temperatures and when stored at high voltage. Problems with rapid charging at lower temperatures. The transportation regulations, which I know many of you on the webinar here are very familiar with. You recognize they are very complex and they can be rather burdensome. And of course, they're higher cost than nickel and lead-based systems. So that last bullet point is worth noting. We've seen the cost of lithium batteries, especially lithium-ion batteries, decrease significantly over the last 3 or 4 years, which is why we're seeing a lot of interest in the lithium-ion batteries in so many different applications, particularly electric vehicles. The lithium-ion battery cell form factors, again, it's important to recognize that there are 3 different primary lithium-ion cell form factors that we see out there. And again, the cells are the building blocks for the lithium-ion battery. So for example, your cylindrical cells, which you see in many or most of the power tools today, the prismatic cells up here, you used to see those predominantly in cell phones, but of course that has moved over to the lithium-ion polymer or the pouch cells. So again, 3 key, what we call form factors at the cell level. Down here, I have a coin cell. Yes, there are rechargeable lithium-ion coin cells on the market, mostly for industrial applications. For example, you can't walk into one of your local supermarkets and buy a rechargeable lithium metal or lithium-ion coin cell. The coin cells that you find over the counter are lithium metal. Okay, this is just an example of a lithium ion and a coin cell form factor that you might see in certain medical or some other industrial applications. If you wanted to look inside one of the cylindrical cells, it's a pretty sophisticated structure. It's got a lot of safety features associated with it, the different anode and cathode materials, and that's where the different chemistries come in. But one of the things, again, this is just a simple diagram of how it is established to provide safety in the event there's a thermal event involving the battery. Again, this is a very elementary diagram of the gasket, the PTC, the vent, the cathode, the anode, the separator. But again, you see it is pretty sophisticated. And again, although these things are manufactured by the billions on an annual basis, it's not an easy sell for manufacturing to make a consistent and safe cell. So the tier 1, what I call the tier 1, tier 2 manufacturers go to a great deal of effort, obviously, to make the safest cell in the world that they can. But it is a very sophisticated process and not as easy as some people might think it is. Another view for a lithium-ion prismatic and polymer or pouch cell structure, you can see the different anode and the cathodes, the separators as well, the gas release vent. So again, the slide that I showed before, one of the challenges, of course, maybe not so much the limitations, but the challenges with lithium-ion cells and batteries is the sophisticated designs that are required because it is a high-energy battery, because you've got a flammable organic solvent. Ensuring that they're safely manufactured and can be safely used in the field. And that's why you see the effort by these major manufacturers to build or manufacture the safest cells that they can. Some diagrams of the different lithium-ion batteries that you might see out there. So again, you're starting at the cell level. The cells are the building blocks for the batteries. As you see here, this is your typical power tool battery that may have anywhere from 4 to 8 cells. Up here in the top right, you can see what I'll call the old notebook or laptop with the removable battery. That, of course, has been replaced almost predominantly by the lithium-ion polymer or pouch cells that are either embedded in your screen or embedded in your in the base of your laptop. So again, with the old days, you had cylindrical cells in these laptops. Today, it's all about polymer pouch cells in either your tablets or your notebooks. But again, this evolution of how batteries have changed from rather bulky items using 18650 cylindrical cells in the top right here to this very sleek, high density lithium-ion pouch or polymer cells that you see in most tablets today and notebooks. But again, on the left-hand side, for the power tool industry, whether it's a circular saw or whether it's a portable circular saw or a drill or a cordless drill or a chainsaw or whether it's a leaf blower, the outdoor power equipment world and the power tool world, they're still using these cylindrical cells. That's the workhorse for that industry. I mentioned the form factors, the different form factors earlier, and how lithium-ion battery are making their way into the marketplace to compete or displace lead-acid batteries in certain applications. These are just two typical form factors that you may see out there in the marketplace today. That, for example, if you like to fish and you're using trolling motors for your small boat, for example, you typically would have bought a large lead-acid battery to power your trolling motor. We're seeing a lot of interest in lithium-ion or this lithium iron phosphate technology being used because, again, it does two things for you. It has much higher energy density, and it's also about 1/3 the weight than your typical lead-acid battery in those certain applications. They're nowhere. The lithium-ion battery is not going to displace lead-acid batteries for your starting, lighting, igniting batteries in your vehicles, but there are other applications, again, where we do see lithium-ion making their way into the marketplace in very large numbers to displace lead batteries. So you can see the same form factors, but again, the lithium-ion offers many benefits over lead depending on the application there. This, of course, creates significant challenges for the lead battery smelters when they're dealing with trying to keep these lithium-ion batteries out of the lead battery smelters, and that's something I know that the lead battery industry and the lithium-ion industry have worked to make sure that there's more information out there about keeping these lithium-ion batteries out of the lead battery smelters because they look so similar, and that is an ongoing challenge. A couple of the larger battery manufacturer, large format batteries, just real quickly on these designs. You can see the term that we often use for these large industrial batteries would be, on your left are these lithium battery modules, which are nothing more than large batteries that are then electrically connected to form a large, what we call a large battery assembly or battery pack. So again, it's very common to see these modules as standalone modules being electrically connected into large battery packs or large battery assemblies. And the beauty of that approach is when this large, let's say this is an electric vehicle battery, when this reaches the end of life, these modules then can be pulled out and then reused or refurbished, or for a secondary use application, maybe stationary applications. So again, it's interesting how that area has evolved. I would say over the last 5 years, where the reuse and secondary use and refurbishing of these modules for other applications is really taken off, and that's a good thing. The circular economy is kicking in. We're seeing a huge benefit for these secondary use applications for these modules that were previously used in an assembly like this. And so that's a really nice approach to the reuse world. Lastly, as far as different form factors and different applications, just very quickly, these containerized lithium-ion batteries, it's a very big industry right now for stationary storage or energy stationary storage systems for the electric grid, backup power, that type of thing. You can see these 20-foot and 40-foot containers in the solar array for solar panel farms and so forth. So again, this is another area where we've seen excessive growth for these very large format batteries that are being manufactured by a number of different companies, both here in the US as well as internationally. So everything, I've covered everything here from coin cells on up to these 20-foot and 40-foot containerized systems that are really nothing more than just a very large battery assembly for energy storage systems. One or two slides here. I was asked to touch on this because this is an ongoing issue that PRBA has been working on, and I know it'll be of interest to the folks that are listening in on this webinar. There's a lot of activity in the fire code world to develop new storage requirements for lithium batteries. There's 3 primary organizations or standards that are out there dealing with storage of products, hazardous materials. In most cases, the National Fire Protection Association has the NFPA 1 fire code. the NFPA 855 standard, which deals with the energy storage systems. They do have a chapter on battery storage, but really where most of the activity is over the last year and a half is with the International Code Council, which is responsible for the International Fire Code. They are, as we speak, in the midst of creating new storage requirements for lithium batteries. They just finished up their committee action hearings 2 weeks ago. They approved a new chapter for the International Fire Code that will have requirements for new permits, new fire safety plans, specific storage requirements for indoor and outdoor for lithium batteries, both lithium ion and lithium metal batteries. And this is big because, again, if you look at the International Fire Code today, the code is essentially silent on the requirements for the storage of lithium batteries. So there's really a hole in that regulatory scheme, the International Fire Code, because we get questions a lot about, okay, what do I have to do, from a storage standpoint? Point me to the requirements for that. And today I can't point to a particular provision in the International Fire Code that says do X, Y, and Z if you're going to store that volume of batteries indoor or outdoor. So this is somewhat overdue. It still has a ways to go. The International Code Council is meeting in September to adopt these new requirements. But you can see, for example, some of the issues that they're dealing with in this new chapter in this particular section will require you to secure a permit, have a fire safety plan, a technical report to evaluate the level of hazards depending on the quantity of batteries that you have in storage, construction requirements like 2-hour fire rated barriers, fire protection system, fire alarm system, and explosion control. Again, this is still in the works. They do, like I said, they meet in September to finalize this. This will not go into effect if it does get adopted in September. This will not go into effect until 2024. So we've got quite a ways to go. Well, this won't appear in the International Fire Code until 2024, but if this does get adopted by the International Code Council, we would expect to see a lot of interest in maybe getting that adopted actually earlier than 2024. And I think that's it. That's all I have for today. Thank you very much. I appreciate the opportunity to speak to you all.
So Eric, you've been made the presenter.
All righty. All right. So I've got up here that are you guys able to see my screen here?
Perfect.
All righty. So I appreciate it having the opportunity to speak with everyone today. Thank you, George, for the update and the information on lithium-ion batteries. I work with Call2Recycle. We are a nonprofit stewardship organization focused on providing recycling solutions for consumers, municipalities, and manufacturers across the country. I want to talk about a couple of different things today. I want to give some information about Call2Recycle and let you understand a little bit about our history and how our program works, some of what the things we focus on and what our priorities are. I want to speak some on what battery recycling actually means in the real world. So once these batteries leave your facilities or other Call2Recycle collection sites, what actually happens with those batteries and what does that really look like? And then I also want to touch some on the education and outreach endeavors that Call2Recycle engages in. So Call2Recycle was founded in 1994, really to address the emergence of new chemistries and producer responsibility for the batteries that were coming onto the market. In the early days, the primary chemistry for portable power was nickel cadmium, and that was really the main focus of our program. But over the years, as the chemistries of rechargeable batteries have shifted, so is the focus of the program. Obviously, the interest today is on lithium-ion batteries, but that's now a large part of what Call2Recycle recycles. Call2Recycle is funded primarily by the rechargeable battery industry, and also by fee-based services that we provide for OEMs and recyclers, from everything from safety solutions to recall-related services. In the United States, Call2Recycle is a voluntary program, except for the jurisdictions where there is where there is mandated recycling programs, so specifically Vermont, Minnesota, New York, and then some new legislation that was passed last year in Washington, D.C. Other than those jurisdictions where recycling is mandated for certain chemistries, Calder Recycle operates as a voluntary program. And we've recycled over 131 million pounds of batteries in our history. One of the focuses right now for Calder Recycle and really for the recycling industry is focusing on what we'd call a hockey stick shaped growth. So it's moving along and it's elevating, but the industry feels that when it hits a tipping point, it's going to escalate very, very rapidly. This has to do with a couple of things. One, batteries are being leveraged now in a variety of new applications and technologies. So as George showed in his picture of all the batteries on his back porch, you wouldn't have imagined that batteries would have been in those type of applications in the past. But also, we're now seeing batteries used in applications that didn't even exist previously. So particularly mobility type applications where an internal combustion engine would not have been a suitable power source. So the growth, for example, in e-bikes and scooters is really just phenomenal right now. So there's new applications, and then there's increasing demand for the existing application, and this really is going to lead to some incredible growth. Part of the concern, though, is managing end-of-life responsibility for rechargeable batteries is relatively complex. Both the supply chains, the regulations, and then also just the mechanics of how recycling programs work. Some of the big priorities for Calder Recycle in 2021, obviously we're focused heavily on collections. We're a public-facing program, and we look to provide collections resources to consumers. About 90% of US consumers live within 10 miles of a free drop-off location for rechargeable batteries. Calder Recycle has a large focus on safety that I'll speak to a little bit more and talk some about Calder Recycle's evolution with safety over the years with the rise of the lithium-ion technologies. And then our third big focus is on addressing those growth needs that I spoke to as these new markets come, as these new applications come into the market. So I want to use this map now to address what battery recycling actually means. So Calder Recycle runs a recycling program, not just for lithium-ion batteries, but for a variety of batteries and battery chemistries. But one of the things that's important to consider that most of you are well aware of is that when you tell a consumer that you recycle batteries, you have to be equipped to manage and transport all variety of chemistries of batteries. It's very challenging for a program like Calder Recycle to say we only accept lithium-ion batteries, or we only accept nickel cadmium or nickel metal hydride batteries. It gets more complicated, as George spoke to, because when you talk about lithium-ion batteries just in and of themselves, all of those sub-chemistries or cathode chemistries that George spoke to, like LFP, lithium iron phosphate, or LCO, lithium cobalt oxide, they also oftentimes have different recycling streams. So this map, if you can see what these dots represent are Calder Recycle's various partners. So after a battery leaves one of your facilities, it's generally going to go to one of our sorting partners in the Phoenix metropolitan area, the Dallas area, or the Detroit area. Because when you collect those batteries, as I said, you're going to get batteries of a mixture of chemistries. So the first step in recycling a battery is to take that mix of batteries and then to split them out into the various types of chemistries. So I've listed on the side here where those chemistries are. There's nickel cadmium, which is an older chemistry, but because of the longevity of life of those batteries, Calder Recycle still collects a very large number of nickel cadmium batteries each year. Lithium ion batteries, which are really the focus of the portable power in the market today. Nickel metal hydride batteries, which were a chemistry that evolved after nickel cadmium, and it's really been taken over by those lithium ions. Alkaline batteries, which are all very familiar with. SSLA, or small sealed lead acid batteries, and then lithium primary batteries. What these various colored dots across the map represent is the fact that most battery processors, physical recyclers, only focus on a single chemistry or a couple of different chemistries. So after collecting batteries from collection sites, transporting them to sorters, sorting them by specific chemistry. Calder Recycle then transports batteries of each of these specific chemistries to our recycling partners across North America, and in many cases also across the globe, for physical recycling and recovery of precious metals. So I highlight this because once that battery leaves your facility, its journey towards going back into that last step of the circular economy, where it actually becomes a raw material for a new good, that journey has just begun, and that battery is going to travel through a variety of steps. What this map doesn't even speak to, though, is when a lithium-ion battery travels for recycling, it typically is going to have to go then for further smelting and further refinement. So it generally at least 2 more subsequent steps before it's suitable for reintroduction into the battery consumer market.
Also new at noon, traffic is moving again from the Ohio Turnpike eastbound on Interstate 76 and he split just before the Youngstown exit. A FedEx truck there caught fire. This is video a witness sent in at 27 First News. You can see across the highway.
So the video I just showed there, I show when I asked the question about when did your views of lithium-ion battery safety change? Calder Recycle's views of lithium-ion battery safety changed on June 5th of 2017. The FedEx truck in that video that's on fire on the side of the Ohio Turnpike was carrying end-of-life batteries, including end-of-life batteries in the Calder Recycle program. When this happened, Calder Recycle realized that we had an obligation to our stewards, to our collection sites, and to the greater community to really evaluate our safety program and our priorities and how we were going to address safe and responsible end-of-life management of lithium-ion batteries. Soon after that fire in June of 2017, Calder Recycle launched our Charge Up Safety campaign, and we recognized the need for not only education and outreach, but some internal skills development and leadership. So when we circled the wagons to talk about what Calder Recycle needed to do to address the increasing safety concerns with lithium-ion batteries, we really came up with a 4-tiered approach. But we felt it was important to foster employee leadership, to improve our own internal knowledge of lithium-ion battery safety, risk sources, how these risk areas can be mitigated and controlled. Also, we knew that we had an opportunity to improve collection site and sorter understanding and performance to reduce the risks of batteries at end of life. We also had opportunity to drive consumer awareness and then work with stakeholders like yourselves to build relationships in order to not only influence public and policy debate, but also to get the best practices and learnings all the way down to the individual consumer level. So one of the first things that Calder Recycle did when we launched our Charge Up Safety program was we took a really critical look at the box that we were using to collect our batteries in. What this resulted in was the introduction of our flame retardant box liner. We introduced it into the market in early 2018 and were granted a patent in 2019 for this box. It's undergone extensive testing, and it's demonstrated to be able to contain fires within the box for mixed chemistries of batteries, including lithium-ion batteries. We feel very strongly about this, about the use of this product, because we know that it works. So these pictures are of actual boxes within our program that have been returned. But we knew that introducing a liner and a box program, so just an engineered control, really wasn't going to be enough if we didn't ramp up our engagement and education efforts as well. The next step that we took on our education and outreach program was site education. One of the most important steps for a lithium-ion battery when it's in transport is ensuring that it's prepared and packaged safely and consistently with the regulations, including things like the special permits that programs like Calder Recycle use as we transport batteries. So in addition to actually introducing that liner, we revised our shipping guidelines. We re-engaged all of our collection sites to require that they engage in safety training so that they're knowledgeable on how to correctly pack and prepare batteries for transport, and then really increase our stakeholder engagement with some of our key big box retail collection partners. As we also looked outward at how we needed to engage the broader community on lithium-ion battery safety, one of the things that really comes to light is the notion of wishful recycling. So this is a Harris poll conducted on behalf of Call to Recycle recently, and really the question that was asked here is, are these items listed here, are these items that can be recycled in your curbside bin? So nearly 1 in 5 respondents to the survey said that batteries can and should be recycled in their curbside bin. One of the things that we're aware of now, collectively in this audience, that we're aware of is that curbside bin is generally one of the worst places to put a lithium-ion battery, because when it's introduced to the mixed recycling stream, it's typically moved in conditions where the battery can be crushed or punctured. And again, that's when you have issues with fires in MRFs and other handling facilities. So taking this information, we continue to look outward to introduce and launch a number of consumer-facing training programs that are all available on the Call to Recycle website, calltorecycle.org, and our safety portal, including videos on safety, battery safety, and then information on a variety of consumer outreach events that we have held in order to filter this information across the population. Additionally, Call to Recycle has engaged other stakeholders, including those within the tool and portable power industries, to launch a couple of public education and awareness campaigns, including one called Avoid the Spark. So we work with folks in the power tool and electronics industries, specifically in the Bay Area, to generate awareness for stakeholders on lithium-ion battery safety. We focused on the Bay Area because we knew it had a high concentration of technology and leadership for green initiatives in the region. And specifically, we worked on in the 5 counties in the San Francisco Bay Area, where there are already very high curbside recycling rates. So with our public awareness campaign, we had over 177 media mentions, which included 196.7 million total interactions and outreaches. And as you can see, our campaign was picked up by a variety of local, regional, and national news outlets. Ultimately, though, what we want to gauge in a program like this is how much did we change consumer behavior with a public awareness and education campaign. One of the key indicators that we use in the Call to Recycle program to gauge safety in the program is how many batteries do we see that are shipped with unprotected terminals. So shipped in a manner where they're subject to short circuit while in transit, which is one of the sources of a fire incident with the battery. So across the period of time from July to December of the Avoid the Spark campaign, Call to Recycle saw an 88% reduction in the occurrences of exposed terminals within our shipping program. So one of the key takeaways with this is that we know that consumer engagement works to actually reduce the at-risk behaviors on that overall risk pyramid that eventually leads to occurrences. So a couple of things to touch on in summary. The portable power is not going anywhere. And as George said, lithium-ion batteries are going to be with us for a considerable period of time. But when you couple the research and development timelines with the manufacturing cycles, every reasonable expectation is that lithium-ion batteries will still be the prominent chemistry in the market for a minimum of 10 to 20 years. Safety has got to remain a top priority, or incidents are going to continue and even increase. Additionally, we know that education is effective and one of the most effective ways to reduce safety risks within recycling. Another point that Call to Recycle likes to bring up is that it's really not just about batteries. Right now, there's a void in leadership on the broader waste management issues. And there's continuing opportunity to educate consumers, including a question that came in previously about what do consumers do with various items and how do we reduce risk in the recycling and end-of-life management chains. So that's all I've got. Thank you very much.
This is Lynn. That was wonderful. Thank you. Kirk, I'm making you the presenter. And just a reminder to the audience to post those questions. Thank you.
turns out I need to give you.
I'm sorry, what did you say, Kirk?
It turns out I didn't have permissions for GoToMeeting to present my screen.
Well,
I'm going to be right back.
we could, oh, he's gone. I was saying we could show it for him. There are some very tricky questions showing up in the questions, many of which I want to know the answers to. So we know which ones are going to get asked first.
All right, that went quicker than I thought. So,
Kirk, if need be, we can also advance your slides for you. Just let us know.
that might be the quicker way to do it.
Okay, Terry, are you able to do that, or do you want me to? Terry, if you're talking, I can't hear you.
I don't have them teed up, but I can if you want.
Yeah,
You
would
want
you
me
mind that we can keep that way? I can keep up with the
Okay.
questions.
Okay.
I'll make you the presenter.
Okay, hold on.
Thank you.
Sorry for the technical difficulties. I think I did the latest update with Apple, and they reset all my preferences.
Oh, that's nice. I know it's always a great surprise to find out what's happened after those updates.
Right.
Yeah. Okay, thank you.
So,
Terry is ready, and just tell us when you want it to be advanced, Kirk.
All right, perfect. And again, thank you, Eric and George, for the background. I think it's going to set up what I'm going to be talking about of, Eric, as you put it, that wishful recycling that our members are dealing with. So my name is Kirk Sander. I'm the Vice President of Safety and Standards at the National Waste and Recycling Association. This has been an ongoing project that I'd be remiss if I didn't say was being shepherded by Anne Germain at NWRA, and was our member Jerry Sjogren from EL Harvey was probably one of the people that was really pushing this. So thank you to them for what they're doing. So just a little quick overview. We're going to go over the background, how we got here, and then going through the guidance document. I mean, some of the big things: contractual language, inbound material control. Then once you get it, well, how do you store it? What do your operations look like to identify them? Because as we can see from George and Eric's presentation, they look really crazy. I mean, and sometimes you get surprised. I mean, my daughter just got a new scooter with light up wheels, and I was like, I thought for sure it had a lithium ion battery in it. Turns out it actually generates its own electricity with a magnet in it as the wheels spin. So that was a nice surprise. But on the other hand, for my daughter's birthday, she got these light up balloons where you blow up the balloon, pull a tag, and it lights them up. Guess how they're lit up? Lithium ion battery, and the thing is about the size of my pinky. And so when my wife and I were about cleaning up the party, we're like, oh, what do we do with these? And I was like, well, these are going in the sand in our backyard so we can recycle them properly. So if we want to jump in right away, if we can go to the next slide. All right, so part of the background on this is we saw a rise in MRFs and in transit. I mean, it's never a fun day when your safety committee's sending you pictures of a truck on fire or a MRF on fire. So Anne had the foresight to establish a working group with Jerry's help between ISRI, SWANA, and NWRA. And over the time, we worked through what are the best management practices for this. So I'm assuming the slides are going to go around. If anybody wants to download the document that I'm going to be going over, they're at wasterecycling.org/safety-at-NWRA, and you can see what is there. Next slide, please. So contractual language. I mean, the best way to eliminate a problem is not have the problem at all. And so as your MRF is receiving product, you want language in there on not accepting lithium batteries. But we all know that's not going to happen because the contract might say it, but that doesn't always mean that the consumer is going to be following that, because there's such a, people see the chasing arrows and go, oh, it's recyclable. So, and then responsibility on unloading. Are you having contract, if you're a contract MRF where you're not only your trucks are delivering, but other trucks, what happens with unloading, disposal? And then can you, in your contract, if you're getting loads at your MRF, can you have curbside education for the consumers of the trucks that are coming into your facility, but also then making people aware of how many batteries are coming through? I mean, when we were on these calls working on the guidance, it was amazing how many batteries per month and even per week were coming through these different MRFs. And it was just, it was shocking. Next slide, please. So in terms of your operations, I mean, how do you do it? You heard me say, when we got those balloons, I put it in my sand. So I have a metal container. Turns out that one of the local coffee makers here in DC and in Tacoma Park makes their coffee and puts them in metal containers. So I repurpose that with some sand, tape my battery up, and that's where my battery sits until I have a couple that it makes sense for me to go up to the DC Fort Todd and transfer station and on a Saturday and have them recycled. Which, by the way, anybody in the DC area, every Saturday, DC will take your batteries and other electronics. So putting them on a MRF, you probably want something bigger, 5-gallon metal bucket, vermiculite or sand in it. And also have a list so that everybody knows what's not permitted in there. And then let your people know. I mean, they're going to come in all kinds of different shapes and sizes. Probably you're going to want to defer. If it's not, defer to, it's more than likely a lithium ion battery than it's not. And so pull it out. So where are they coming from? You want to check, your tip floor, how you're sorting, magnets, baling, and then your identification. We take the picture of George of everything that's in his house. I was at an ANSI meeting for the Z245 standard, and we were talking about this for the 0.4 standard. And I just started thinking about all of the lithium batteries that I was carrying, not only with my laptop, my phone, my headphones, my battery pack to charge my computer or to charge my phone. It was just that's one person. So how do you identify them? What do they look like? And I think George said that some of these also produce their own oxygen. So then what do you do for your operations for once they're removed? Making sure you have leather welding gloves in case they do start catching on fire. Where are places that you can find them, sorting stations. And then once you get it, make sure you cover them so that then, like Eric said, the tips don't touch. And also separate your damaged and undamaged batteries. And then also, like I said, tape your batteries. Next slide. So facilities, fire suppression. What is your background? What is your operation for fire suppression? A lot of our members are adopting a one fire extinguisher and then get out and call 911 operations. What is your housekeeping so that a small fire doesn't get into a much larger fire? Making sure that things are consistently checked to keep processed and unprocessed materials from each other. And then one of my favorites is always using a checklist. That way your operations have what you want and you go through it. I'm sure a lot of us have heard about the rock band in the 80s who had the green M&Ms in the green room. It's a good way to check the checklist. And also talk with your employees about egress so that they know how to get out if something does happen. One of the things that Jerry always talks about is how close he is with the local fire department in his area. You don't want the first time you meet the fire chief or the battalion chief for your facility, when your facility is smoking or on fire. You want that relationship to start on a nice day where you can have a cup of coffee and joke a little bit and get to know each other, versus a, hey, so who are you? What are we doing? And what's this facility? That will not end well. I mean, hopefully it might not end well if you have a good relationship, but at least you know you're not tripping over each other. So one of the things is get to know your local emergency response team and have a written plan so that you can, once you get through it, you can drill on it, you can exercise on it. But the one thing I would say to be very cognizant about is, where is the line of a fire brigade on the OSHA standard? So work with your local OSHA office. There's very specific pieces on the diameter of the pipes of hoses you're using, training, if gear gets type of gear that gets distributed. So I'd be very cognizant of that. OSHA is working on rewriting its fire brigade standard right now for volunteer and professional firefighters. So just be on the lookout for that. Next slide, please. And so getting back to sort of the contractual piece is also, how do you engage the consumers? I mean, basically, I'd say if we could get every consumer to see George and Eric's presentation, this would be a much better place. I mean, having people understand it. I mean, even talking to my own family, they're like, oh yeah, we just put it in the trash. I'm like, what? No, don't. And so how do you engage that? I mean, how do you tape it? How do you bag it? And I mean, the other thing is, you don't want to ever put it on the curbside. I mean, that's just is not going to go well for anyone. So with that, I know it was quick. Next slide. Is there any questions?
Oh, there's a lot of questions. Believe you me. So thank you. That was great, and everybody. And so at this point, I'm Lynn Rubenstein, and at this point, we're going to ask that all the presenters there you go. There, that's all excellent. And feel free to keep putting the questions in the boxes. I want to say, Terry, maybe at this point you could start tracking them in case there's any I overlook, which is entirely possible. But I'm going to tell you that we've had a couple of people, and this is for anybody, who have asked a very basic question, and perhaps it's worth just hitting the answer very firmly. Are lithium batteries recyclable? Is that what happens, or do they get thrown out? What literally happens? So I think that probably several of you are able to answer that one. I don't know if George or Eric, you want to go first on that?
Eric, I'll defer to you on this one.
Sure. Yes. So the first answer is yes, they absolutely do get recycled. They don't get landfilled. In the world of recycling, there is, particularly with an article, which a battery is an article. So as you saw the picture of that drill pack, there are not just the individual cells in a battery. There are the plastic cell holders. There are circuit boards. There are housings for the batteries. So there's a lot of different things that make up a battery. So when we talk about recycling and how much good stuff do you get out that you can put back into the market, the first question you have to ask is, well, what's in the battery itself, and how much of that is able to be recycled in current processes? So, and that's what we refer to as the recycling efficiency rate. For every pound or kilogram of material that you put in, how much of it comes back out? So generally that number by mass is going to be in about the high 70% ranges. And that's because, and the material that's lost is typically going to be some of the non-metallic material that's burned off in a kind of an older paradigm recycling process. That number is increasing as newer battery recycling technologies are coming to market. For just the cell portions of the batteries, there are technologies on the market where in excess of 90% of the mass of what's in that cell is able to be recovered and reintroduced into the market. So they're not just, you know, recycled and driven around in landfill, all those little dots that were on that map. They're recycled and moved back into the materials market.
So not just going for a ride.
Not going for a ride. But to grossly oversimplify it, first you have to do something to discharge the battery, which so oftentimes there will be batteries will be frozen, or they'll go through a brine bath, a salt bath to discharge them. Generally, they're going to need to go through a size reduction process. So they're typically either shredded and ground up, or thermally size reduced, which is like a lower temperature burning. There are then mechanical separation processes, so things like magnets and eddy currents, shaker tables, sink floats, and then that's where you kind of split between the older way of doing it and the newer way of doing it. An older way is what's called pyrometallurgical, so a heat treatment process where different metals melt at different temperatures. You're able to physically separate and recover the nickel and the cobalt and various other metals that are in the batteries. And then some of the newer technologies use what are called hydrometallurgical processes, where you use chemical leaching processes in order to precipitate or separate out the various metals within it. Those hydrometallurgical processes, as I said, they're newer. They typically require less energy input in order to run, so they're considered to be a bit more sustainable. And then you're also able to recover more different kinds of things. So for example, in most older style pyro processes, no lithium is recovered in a lithium ion battery. Whereas in some of the newer processes, lithium can be recovered.
So what becomes of the lithium? You know, what you kept saying into the marketplace. So what would be the next life?
So once you get something back to constituent metals, they can go into just about anything. So nickel, for example, is used in the production of stainless steel. So a lot of nickel goes back into the steel market. Ultimately, a lot of it does go back into the battery market. One of the things to consider is that just as that battery end of life process is complicated, the battery beginning of life process is complicated too. So those cells are the result of multiple steps in the battery manufacturing process. It typically happens across several continents. Ultimately, though, I would say that most of it goes back into what's called the cathode precursor manufacturing. So before you make a battery, you have to make the cathode material that goes into it. And before you make the cathode material, you have to make the cathode precursor material that goes into it. And so, you know, if this is your circle, right, and this is end of life, and down here is where you have your battery, there's a whole lot of steps right there. And so it's pretty substantially complicated. And the lines start to blur. When is it end of life and when is it beginning of life again?
Well, that's going to make me look at all batteries with awe. That's pretty amazing.
I mean, it's actually very, very interesting, and it's kind of wild when you actually look at the journey a battery makes to become a new battery.
So a question, I'm going to build off of something that you said, Eric, and ask Kirk about this. So when you began to describe how is a battery literally recycled, you use some terms that those of us in the solid waste recycling industry might associate with a MRF, like eddy currents and magnets and things like that. So Kirk, do these things actually get separated? These things, you know, lithium batteries, do they get separated in a MRF, or what happens to them there?
Yes, I mean, that's ultimately the goal. I mean, you'll see them on the pick lines. So there's people who are actually physically picking them. If there's ferrous metal potentially in it, they'll get picked up on the eddy current or the magnets. And so depending on where they are in the process, that they will actually come out. So that's why you need those 5-gallon metal buckets with your vermiculite and sand. So once you get it, you can properly isolate it so it doesn't make a bad day.
Okay, great. So George, are there any advancements in fire suppression?
Any advances in fire suppression? Well, it
For
depends
this
on.
stuff, I mean, for this, for lithium batteries.
Well, let me clarify one thing about suppression for lithium batteries. So there seems to be a lot of misunderstanding about the best suppressant for a lithium-ion battery fire. The best suppressant for a lithium-ion battery fire is water, and lots more water. Okay, so we all know lithium-ion batteries and lithium metal batteries burn very hot. I mean, they'll burn at 500 or 600 degrees centigrade when they go into thermal runaway. That's no secret. There's plenty of data out there. By using water, you're going to suppress the fire. You're going to cool the cells, whether it's a lithium-ion or a small, relatively small lithium metal battery fire. Water works well there as well. And certainly there are companies out there developing other fire suppressant materials for lithium-ion batteries, and that is a growing marketplace for sure. But there's nothing that jumps out at me right now that really is a game changer in terms of suppressant materials. There's plenty of things out there that are effective, but again, when it comes to the best suppressant, it's still going to be water or some sort of water-based system, maybe foam or something like that.
So what makes a battery catch fire? Do they spontaneously combust, or does something about their environment or setting have to be in place for them to, become horrifying? I don't know who wants to answer that.
I'll start. I think Eric will probably chime in as well. I mean, some of the fires that we've seen over the years could be the result of poor manufacturing processes where there's contaminants inside the cell that compromise the separator between the anode and cathode. And when that happens, that's when you can get that thermal runaway event. When that anode and cathode come together, the energy gets released, and there is a flammable organic solvent inside those cells. It's not an organic solvent where you can shake the cell and you can hear it. It's embedded in the system. It's just a small amount, but it's enough to create certainly a flammable characteristic associated with the battery. So manufacturing defects, sometimes when cells get crushed, and if they're at a fairly high state of charge for lithium ion at least, that could result in a compromise of the separator as well and cause an event. Also for lithium metal batteries, we've seen lithium metal batteries like the cylindrical cells, if they get crushed, they certainly also can release a large amount of energy. And again, because some of them do have flammable constituents, and if there's a spark, that also can cause a fire. In a closed scenario, in a closed container scenario, just very quickly, recognize that when lithium ion cells and lithium metal cells, when they vent, if the vent releases, they could release flammable gases. And if there's a spark, that also can cause, obviously, an event there as well. So again, that's why it's so important and I'm really glad to see that it's a fairly large audience here to understand that there certainly are risks associated with lithium batteries, but it is still a very, very, very safe technology. We all use it every day. We all know that, but it does take great care in terms of handling both as a new product as well as end of life.
Kirk, did you want to contribute to that response? Or Eric?
Yeah, I would echo George first off in saying that a lithium-ion battery is a fundamentally safe product. There are a variety of mandated test protocols that are generally called the UN 38.3 tests. And so batteries that are brought to market as anything but a prototype have to go through a very rigorous series of tests before they can be transported based on the non-prototype regulations. So fundamentally, batteries are safe products. There have absolutely been manufacturing issues. There's been some very, very public and very serious ones. A battery has got the negative part, the anode, and the positive part, the cathode. And when it all comes together really quickly, that same energy that comes out that powers the device, all of that energy, when all of that energy comes out very suddenly, it results in heat energy, which is where that fire comes from. In the context of end of life, we see battery fires coming from two primary sources. So I'm going to take the manufacturing defect part out of it. When batteries are crushed, you get all the negative and positive coming together at once. That's what makes curbside dangerous. What makes batteries in the context of a MRF, where you've got mechanical material moving equipment, that's where a lot of that danger comes in. So a battery being crushed. And then the other is a battery being short-circuited. I think it's important for somebody to know that if you've got a battery and you've got a piece of metal touching one of the terminals, it's not going to create a short circuit. what's required in a short circuit is the positive and negative terminals of a battery coming into contact with each other, and then you get a feedback loop that just releases heat. Another thing that's less common in a recycling scenario, but very important for general consumer awareness, is overcharging or unregulated voltage can also be a source of a battery fire. So taking batteries and using them in applications that they were not intended for, like vaping devices, is a fundamentally risky activity. Batteries, as I said, go through a lot of tests, but batteries are a part of a broader system. So you really can't just buy eBay 18650s and start to DIY slap them into things and not have issues.
Okay. So both of your responses touched on, the tone of several of the questions. So first, I'm going to say that some of the questions related to how do I, Lynn, prepare a battery or a device with a lithium battery in it for recycling, before I take it to a collection site. And the, sort of the companion to that was, how do I safely store devices with lithium? So I'm still using it. It's still going. I'm not ready to recycle it. What should I be doing, if anything, as a consumer, to be sure that things are as safe as they can be? Kirk, do you want to say anything about that? You with your bucket?
Yeah,
It was a great idea.
Yeah, a bucket with sand in it and taping the battery, and then you call Eric and get his container and go from there. I mean, one of the things, so being that cell phones are ubiquitous everywhere, I mean, our 5-year-old wanted a cell phone, so we had an old one, and we let her play with it. And then after a number of these meetings, I went, wait a second, we never took the battery out of there. And so they now have all been removed, and the ends have been taped, and they've been put in the coffee can that's metal with sand in it, and have now been driven up to the Fort Totten transfer station. But I mean, luckily all those batteries were still intact. There was no bubbling with them. I would have started freaking out a little bit more had the battery been bulged or in anything. But I also then defer to Eric on what the next steps are once they get taped and put in sand and you can get them to a facility.
And thank you, Kirk. And if there's before ready to be recycled, any storage handling precautions as an individual I should consider?
I would offer to.
Yeah.
Sure, go ahead.
I would offer I would really strongly encourage everyone to only use OEM chargers, for example, because just as I said, batteries are part of a greater system when they're in a device. That charger is a part of that system as well. So only using OEM systems. I personally would not leave a lithium-ion battery or a device containing one sitting somewhere where it was in direct sunlight for extended periods of time. But as far as things to do, I work in the battery world, I live in the battery world, and I charge my phone overnight with an OEM charger. I don't have specific concerns about leaving a laptop plugged in because there's sophisticated voltage regulation. It's not like kind of older style lead acid battery chargers where you can overcharge something. As long as you're doing it as a part of that holistic correct system, then you can leave batteries on the charger. They're not just going to keep getting juice pushed into them. That's not how they work. But making sure that that you're not in a position to where your batteries are being abused or damaged. When you fly on a plane and they say, if you lose your phone, hit the call button, don't try and get it yourself. The reason they do that is they don't want you moving the seat around in a place where your battery is going to be crushed and go into thermal runaway. So I would offer, make sure that you understand that when you're using a device, that if you damage it, that's when risk starts to come in.
Mm-hmm. Good point. Terry, I have many more questions I could keep going through, but as you know, I switched my attention. Are there some questions that have come in since we started this phase that you'd like to present? I can keep going, but I don't know if there was any particularly.
I thought some of the questions about labeling products were interesting.
Okay, so yes, thank you. So yeah, several people commented either with words of advice or with questions about labeling, and they sort of fell into two categories. Why does it say please recycle, implying do what I normally do with recycling, as opposed to a more specific set of directions? And why are there the chasing arrows on these devices? All kind of miscues to your enthusiastic recyclers. So why does it say that? And is there a way to cut it out? So I don't know if who might want to start with that one.
I mean, I can speak to that. I'll start, and Eric maybe,
Great.
and Kirk maybe would jump in. I mean, recognize that, you know, when it comes to either lithium, mostly lithium ion batteries, but also it applies to lithium metal batteries as well. I mean, these batteries, many of the lithium ion batteries are manufactured over in Asia, and they're imported and they're shipped all over the world, right? There's very few lithium ion manufacturers, battery manufacturers in the US. So as a result of that, it's a very international, you know, industry that where these batteries go all over the world for all those devices that I showed on my first slide. And different countries have different requirements for labeling. They can't label their batteries for, say, California or some other state in the US that says, you know, do X, Y, and Z. You know, so they're often labeling their products for maybe the European batteries regulations that requires the crossed out wheelie bin and the chemistry symbol, right? So the industry does the best they can to comply with national and international requirements when it comes to labeling. It is unique here in the United States, we know, with that whole three chasing arrows thing, but that's an issue the industry is certainly working on. Those are legislative challenges that we currently are facing in several states about labeling of batteries. But it's something that we recognize is causing a lot of confusion. But that's one of the benefits of the Call to Recycle program, which Eric can speak to. You know, they have that Call to Recycle seal that makes it very clear that the lithium ion or nickel cadmium or nickel metal hydride battery is recyclable, and it can be, for example, it can be dropped off at a local, you know, Home Depot or wherever, a big box store for recycling. So yeah, the recycling issue is a challenge, no question about that. Or as far as the labeling issues go, it's just that diversity of batteries and also the different requirements in different countries has created this situation that certainly has caused confusion here in the US. We recognize that.
Right. So we just have a couple more minutes. And Eric, I don't want to cut you off. I want to say that there's been a flurry of questions, and I'm going to about with two topics. One I'm going to answer. What does OEM mean? And it's original equipment manufacturer. So if you buy, you know, an iPhone or a Samsung, use the Samsung or iPhone power charger. Can I go and get a generic one at Walmart though? I mean, I can get it. Should I use it?
You know, it's when we're talking about charging systems, I think, you know, things like a lightning cable, there are plenty of aftermarket third party that make OEM compliant devices. You know, I can't speak to the suitability of every single charger that's out there. For something like that, you know, obviously, for example, a microcharger on a Samsung or Android type device, you know, those are going to be broadly interchangeable. And then your bricks are all going to be the same voltage. So the part of what's important to consider though is that brick part of it. Those are not all the same. There are certain ones that put substantially higher voltage output than others. And the one that comes with your iPhone, that's a 5-volt output. And you can buy one that will put substantially more than that out. So for things like laptops, I would only ever use an actual OEM charger and not a third party personally. For something like a micro USB or a lightning cable, I think that as long as it's from a reputable manufacturer that's making a licensed product, I would be okay with that personally.
Right.
Yeah, let me,
Okay.
I
Oh,
just
go ahead.
I need to speak about 30 seconds to this issue. I promise it'll
Sure.
only be 30
No,
seconds.
that's fine.
This issue is particularly sensitive for the power tool industry and outdoor power equipment industry, where you have, you know, a lot of aftermarket chargers and aftermarket batteries that look very much like the original equipment manufacturer's product. So I can't emphasize enough for the 485 people still on the line here, how important it is to be buying those quote unquote OEMs, original equipment manufacturers products, even after you need a new battery. So if I need a new battery for that vacuum I showed you, I will be calling up the original manufacturer, going to their website and ordering one, because I know it'll be safe and it'll be compatible with the charger. Those products, as Eric said, are often tested as a holistic system. The product, the charger, and the battery all meet certain UL standards, for example, and there's a reason for that. They all need to be compatible because of their high energy capacity and the ability to properly charge, not overcharge, et cetera. So again, my plea to the masses here about buying OEM products. It's not just it's not just because I want you to buy our members' products. I just want you all to be safe. That's all.
Yeah, no, and that's a great example, George, of one of those things that really sticks out of where it's particularly important. But less so with that micro USB charger, but when you're talking about tools and devices and appliances, yeah, that's where you absolutely have got to use original manufacturers produced equipment.
Great.
Can
Thank
I follow up with a question that sort of relates to this topic, which is, do you need the batteries to be separated from the product prior to processing, or do you need, can you process the entire product for recycling? If you're, you know, if
Historically speaking, the processes for recycling and recovering the what you're after, right, in e-waste is different from the processes for what you're after in a battery. There are some newer processors who are, so in e-waste, you're generally after things like gold, silver, copper, palladium, the things that you would sometimes hear called sweets, those types of metals, versus the metals that are in lithium-ion batteries. There are some newer paradigm processors and you know, right on the cutting edge of technology that are able to recover all of those metals in the same processes. And that's really encouraging because of what we see with embedded lithium-ion batteries.
Right. Wonderful. Well, that is tremendous. There were, we don't have time to answer the questions, so I'm just going to give a call to recycle, a plug here. There were many questions about tape. What kind of tape? Where on the battery to tape them? And I know that on the Call to Recycle website, there is information about that, so I encourage people to follow up there. I know that Terry joins me in just saying, outstanding, George, Eric, and Kurt, yay! And boy, the comments and the kudos have been flying in, so, and well-deserved, So I want to note that we have several more webinars coming up. We have one on Thursday, which Terry didn't mention at the beginning because I forgot to mention it. So Thursday is about life cycle assessments. It's going to be fascinating. Then we have a follow-up to this webinar a week from today, which is going to get a little bit more into depth about the management and movement of materials and fire suppression, very important. Then in June, we're going to learn about all the various environmental benefits calculators are out there and what they can and cannot do. Then we have another webinar on lithium batteries, a new one just scheduled for June 14th, that's going to talk very specifically about the recycling of these batteries. What happens and what sort of enterprises are there out there? Then we have another webinar about EPR in June, taking a close look at packaging EPR and the funding approaches. We're partnering, NEMOA, NERC, and are partnering with PSI on this. And I say finally, because that's the only thing that's left on this screen, but not because it's the final webinar. On July 14th, we're going to hear about the upcycled food economy. So links for all of these are on NERC's homepage as well as on the NEMOA website. The PowerPoint presentations are already on the NERC website on its webinar page. The recording will be available by tonight. And you will be receiving an email tomorrow with the links. And yes, you will be getting certificates of attending. So with that, we're going to say have a fabulous spring day, everybody. And again, thank you so incredibly much for being with us. And we'll say goodbye. Take care. Bye-bye, everybody.
Thank you.
bye, thank you.